Welcome to another GCBASIC tutorial. This is for the 16F175 chip family. That's 16F175xx, meaning that there's a number, I think there's 12 chips in this family. This is part one, the basics. Turning on an LED, but actually also going to be turning it off. So this is November 2025, and what really is important is that you like and subscribe. I'm in it for the the thumbs up and the likes, okay, and the subscriptions. I get nothing else from it. Let me reassure you. Let's just so like and subscribe. So what is this particular chip, 16F175? I'm using a 5.6. There are many other devices out there. They are high performance PICs. They have digital and analog peripherals, good ADCs, analog and digital signal conversion, multiple interfaces, which we will be using, okay, in these tutorials. Pulse width modulation, different types. Um, we also have some configurable logic cells, which is really custom hardware logic that you can control. And integrated op amps. I think my chip has 4. Now, it comes in different devices, from 14 to 44 pins. I'm using a 28 pin. Okay, so it's you pick what you need. These demonstrations will work across all the range, obviously within the constraints of the number of pins. If that port is not available, then quite clearly on a particular footprint, it's not available. So a quick word on what we're going to be covering. So we're going to install the hardware, make the board work, make the LEDs work. We're going to go right the way through to some very low level stuff, but we're using this walkthrough over the next 20 videos. GCBASIC, quick overview. It's an open source compiler for PICs and AVRs and LGTs as well, which isn't shown, and it supports these chip families. And that's great because it now works on these relatively new chips. So what we're going to do is assume that you've done the GCBASIC and GCStudio, which is the overall package of software. And if you haven't done that, there's a YouTube link here, and I'll put that in the link, and it will take you through how to download, install, and do the initial test. You need to do that. You need to have installed your programming software, and you need to make sure that you can find the PIC that we're targeting, the 16F175xx. If you don't do those 3 things, the rest of this is pointless, obviously. So I've installed my GCStudio, GCBASIC. Now I'm happy with that. So the hardware I'm going to be using, I'm going to use the same hardware. It's a prototype board. I power it from 5 volts. I have a programmer, LEDs and resistors. And that list will get longer and longer over these 20 videos. And the sort of thing I'm going to be showing is a diagram like this. It's got ports and other things. And I'm going to be using today port B. Explicitly, I'm going to use port B.0, and on that I have an LED. It goes through a resistor. And my board layout is like this. I've shown you this on purpose because it supports an awful lot of stuff. And I've got the red chip sitting in my board with in the PCB. It's exposed in a row of headers, and I've connected that row of headers to an LED. What does that look like? It looks like this. It looks like that. That's how it actually looks in reality. But we can see this, and that's quite useful because here's the actual thing. It's sitting there, the LED is flashing to prove it works. Look, I've got a programmer, and it could have been any of these programmers. I'm picking up a handful of programmers. It could have been a PIC1, PIC1, whatever it's currently called, don't know. PIC1, PIC2, my favorite clone from PIC or it could have been my favorite chip, which is this, PIC Plus. Hey, you can buy this. Look, it's tiny little programmer, and it works. And I'm going to prove to you it works by flipping out to my desktop and showing that it's working. So if I just press If I start up GCStudio for you, then we can see the action all happen. So if I press zoom in my desktop a bit better, type in GCStudio, I've installed the software, it will open it up for me, which is fantastic. So in I go, and it's now opening up somewhere on my desktop, GCStudio. Now, of course, I've got PowerPoint open, so it's confusing me where it is on my desktop. Let me just come out of PowerPoint for a second. Type in GCStudio again. Maybe I missed it. I did. I must have missed it. And I come up with this screen, which is actually the GCStudio entrance point. And this is quite useful to have a quick review in here, because I can open folders, open a file, create new projects. But what we're going to do initially is open a folder. And the folder was on that PowerPoint slide. And I'll show you that in a moment. But let's just go in there and open up the folder that we will be using. And I'll share this with you shortly. The folder we're using is in your demo folder, vendors, GCBASIC demo board, PIC16175xx chip range demonstrations. And I click on that and select the folder. It actually starts up the IDE. It starts up the IDE with it, and I'll zoom out to my desktop. It starts up the IDE for me in that folder, and we'll look at those files very shortly. First thing I want to do is make sure that I'm talking to the PIC. How do I do that? Well, within the IDE itself and in GCStudio, a lot of tools are installed, and I've installed my programming software, and I can get to that by pressing function key F4. And inside of here, in the IDE, function key, if I type in PIC, it takes me to PIC Plus GUI. If I hit enter on that, it will take me into the GUI software, and this is the Windows software that we're going to have a quick look at just to see what's happening. And we can see here already that we have got in this device line here a 16F17556, and it lists out all the different components. It says it's got 16K of RAM, 128 of EEPROM, 128 of this and that, different voltages, etc. And I can erase it, and if I erase it, that LED will stop. So let's see what happens. If I do that and I press the erase button, it's empty, it's gone, there's no, if I put some power on it, it's gone. It's no longer live. So let me just put some power on that just to show you, because I can put power on it. Now we've got you can see the LED is flat, turning the power on, there's no LED flashing. We are talking to the microcontroller via the programmer. It's just hooked up with a USB, very simple. Let's look at some programs. But back to PowerPoint. We'll see where we got in my PowerPoint. That's where we got to. So we've got some demonstrations. I've already shown you the folder. It's demonstrations, vendor boards, GCBASIC demonstration board. That's what that big board is called. 16F175xx chip range demonstrations. And what in there, we're going to look at blinking the LED, set the LED on, then we're going to blink it, and then we're going to do some different stuff. And we'll review that in a moment. So let's just go directly into the IDE. So the IDE is open, and a couple of key you need to know. Once you're in a folder and there's nothing displayed, Control B, or select the icon at the top left, which is the Explorer. And you can see there's a series of files. Well, let's have a look. Let's open one up and walk through it. 10, hello world. Control B shuts that window as well. Control B opens it and Control B shuts it. Anything in green, either it's a low light green or highlight green, is comments. Read those in your leisure. But this program is just simply going to set an LED on. What do I need to do to tell the compiler what chip is attached? I need this line here, hash chip. Then I tell it the name of the file. And I could put over 1,000 files in there. It doesn't, chips. All the configuration is in automatic. You should also have this line here called option explicit that says that you must define your variables. The rest of it is commentary for you to read in your leisure. But essentially, all I'm saying is that I want to set port B.0 as an output port. So I go dir port B.0 as an output. And I'm going to set that to on by setting it to 1. That's on. 0 is off. So port B.0 equals 1. We'll turn it on. That's it. That's the whole program, which is turn a port on. If we can do that, that's a great step forward. How do I compile that into a program that can be downloaded? GCBASIC is rather simple. And you can press this function key F4 and you'll get a list, and you can type in make. And if you type in the word make, you can make the ASM file, which you can look at. You can make the hexadecimal file, or you can make the hex and flash, which is function key, the same as pressing function key F5. There's also little icons on the top right hand side as well. We'll look at those later on. Make hex and flash, and it will open up a secondary window in a moment. It will go through the process. If there's any errors, they will come up. It will then pass the hexadecimal file it's generated to the programmer. So rather than have a mystery whilst it's doing all this, I'm just going to change my view and put the camera on there. There's the camera. So I'm going to press function key F5 in the IDE. There's the window pop up. It's already compiled it. It's generated the hexadecimal file, and it's now turned the LED on. There are other messages in there, but let's not confuse ourselves with what's going on in that window at the moment. The window pops up automatically. If you want to get rid of it, on the right hand side, you can press the close or Control J, same thing. That's our first program. That is like the hello world. And that takes just a few seconds to do. It's very simple in GCBASIC. Define the chip, option explicit, good practice. Set the direction of the port, so an output, and then set it to high. So let's pretend for a minute we didn't put the out in it. What happens? Let's just test it. I commented it out. It's going to program it. The LED comes on because the default is set. If I power the programmer off completely by coming out here and just turning the power off, I wonder if it. There you go. Look. So the default is an output. Good practice says you should always define your inputs and outputs. If you make an error, I'll make an error in here by typing in some gibberish. Function key F5 to try and compile it. It says syntax error. If I click on the syntax, it takes me to the line with the error, which is underlined, and I can correct my error. Function key F5, it will now recompile it. Let's make the LED flash. Shut that window down. Let's open up the Explorer and open up file 020 blink GCB. GCB is the extension that is used by GCBASIC. Click on it, and basically what I've got in here, Control B to shut that window. Same. Anything in green is a comment. Hash chip, said that before. Option explicit. What I'm saying here is same as before, set the port B as an output, and then do a loop. Do a loop forever. So anything between the do loop, it has a little line on it, is repeated forever. Do it loop forever. It says wait for 1 second, set the port low, turn it off. Wait for 1 second, set the port high by setting it to 1. You don't need the word set. You can put it in, but you don't need it. Will that compile? function key F5. The LED is flashing, which means it's worked. So let's look at what is in here extra. Where did it get the weight from? I can specify different units of weight, but if I want to know what the syntax is, highlight the word, press function key F1, and it will take you to the extensive help file, weight. It's a fixed length, there's a time and units, and those units are microseconds through to hours. So you can construct whatever you like. And that's calculated for you. So if you change the frequency of the chip, that weight will always be consistent. Now, that weight isn't highly accurate like an external timer, but it's good enough for military work. Let's look at the next demonstration. 030, blink another way. This, I'm going to shut the Explorer. This blinked the another way. Interesting this. We've got the same start at the beginning, which is hash chip and hash option explicit, but I'm defining a constant. And a constant and using constants is very, very important. It's good practice. And we do that by saying hash define, the string, the name, LED1, and the port. And so every time I refer to LED1 now, it's going to be just replaced with port B.0. Fantastic. So that means I can then say, set my LED1 to an output. So if I change the port, I just change it in one place now. I don't have to go through the whole code. I'm going to wait for 100 milliseconds, and then I'm going to do LED, that LED, port B.0, not. So it inverts it. It's a way of inverting the LED, and it's quite fast. It's even faster on AVRs because they're even smarter. But we're looking at a PIC, so it's going to say what is the current value. It's going to examine what the value is. It's going to ensure that it is the right value. It flips it over, so if it's a 1, it turns it to a 0, and 0 to 1. Function key F5 to test that. Programming it. And you might say, it hasn't done it. Well, what we can do, of course, is change the value here. We'll just knock the 0 off the end there. Reprogram it. And you can already see that the program at the top there is flashing its LEDs, and now it's flashing faster every 500 milliseconds. We could put an oscilloscope on that, but trust me, it's doing its stuff. I'll revert that and save it. Standard save, Alt FS. Very, very simple. So what we've just seen there is how to blink an LED. We saw we have this thing called a constant, which we'll be referring to more and more and more. Basic commands of dir and wait. The do loop's implied. Extremely simple. So next, we're going to make 4 LEDs flash in sequence. Enjoy.